Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will continue A-level mathematics M1 lessons, and this is lesson 2.4. And in this video, we will cover free fall under gravity. This point, right? And the above points we have covered, and you can find the link in the description below. So let's start. Free fall under gravity. The uniform acceleration formulae, we have seen SWOT equations, right, in the previous videos. So uniform acceleration formulae may be used when considering the motion of a body falling under gravity. In such cases, the acceleration of the body is 9.8 meter per second, and this is commonly recorded as g. This is the information. Acha, by the way, usually in physics students use it 9.8 meter per second, but when you will solve M1 paper A-level maths, you will use 10 meter per second square acceleration, right? You will not use 9.8. I have written here because this is mostly students use in physics. If the motion is vertically upward, the body will be subjected to a retardation of 9.8. We have already seen in the previous case, retardation. In this case, we are talking about speed is slowing down, right? Now, very important thing is arrow convention. This is where students usually make mistake, so we need to understand it. In any example which you will see afterward, care must be needed to ensure that the direction of the arrows of vectors are all in the same direction. For example, if I am saying u is equals to 25 meter per second, it means I am throwing the ball up, and it is thrown with the velocity of 25 meter per second. Now, acceleration is due to gravity, and it is always acting downward, always, right? Even when you throw the ball up, because of the gravity which is acting downward, the speed slows down, right? We are not talking about here resistance and other things. We are ignoring those aspects. So, when we have to use these values in the question, all arrows of the vectors must be in the same direction. So that's why 9.8, which is acting downward, will be taken as minus 9.8 to change the direction of the arrow. You know, when it is 180 degree turn, in the vector, the sign changes. So this is the reason it will work like that. So we will focus on this concept in the next examples. First, I will explain one example, then 2 examples will be your test for understanding. You will put the video on pause and solve it, and I'll show you the solution. Okay. A brick is vertically downward, thrown vertically downward, right? Just give me 1 minute. Okay. The brick is vertically thrown downward from the top of the building and has an initial velocity 1.5 meter per second. Now, what is given here? If the height of the building is 19 whole 2 upon 7 meter, I have intentionally taken the values which are not very comfortable for students, like integer values, because these are expected. You should be comfortably using these also. Initial velocity is always represented by u. We have already seen the symbols in the previous video. It is thrown upward, so arrow is upward, right? Now, what is happening? Oh, sorry, it is thrown downward. My mistake. It has been thrown from the top of the building. Just a second. Okay. So it is downward. And the height of the building, so that will be the displacement covered by the brick, is 19 2 upon 7, which is in fractional form will be equals to 7 times 19 plus 2 is 135. Please keep the calculator with you if you want to calculate along. And arrow is again downward because from the top of the building it is coming down. And acceleration will also be acting downward, which is 10 meter per second square. So in this case, if you see, all the arrows are acting downward, and what we have to do, we have to calculate the velocity with which it will hit. So we have to find out 2 things, velocity and time it will take to reach to the ground. Now, which SWOT equation you will use here for the first case? What do you think? If I use, for example, V square is equals to U square plus 2AS. Yes, that makes sense. Because first I have to find velocity. So U, A and S is given to me. That is fine. So U is 1.5 meter per square. 1.5 square. A is 10 and S is 135 upon 7. So please take out the calculator and let's calculate with me. Okay, I will also use calculator to figure it out. Okay, so V square is equals to 387.964. By the way, in values which are not exact and they are non-terminating, write down up till 4-5 decimal place, and then after that you will round it off to the 3 significant figure, which is the requirement of the paper. So, or you can say 9.7 meter per second in 3 significant figure, right? So highlight your final answer always. Oops. Let me just, okay. So now part B is the time taken for the brick to fall. So now we have to find out the time. So let me reduce this size so that I have more space. Okay. Again I will use V is equals to U plus AT. Why? Because now V, U and A, I know it. Achha, now I will use actually up till 4-5 decimal place the actual value. Never use the rounded off final value to calculate the answer of the next part. Okay. So 1.5 plus 10 T. So now pick up the calculator. T is equals to 1.819 seconds, which is equivalent to 1.82, because you have to write answer in 3 significant figure, right? Okay. Now next is your test for understanding. So you can put the video on pause. I have solved this question, so you can take time, maximum 4 minutes, and then in this case the ball is going up, so you have to be careful about the arrows. Okay, I'm showing it to you the answer and you will put the video on pause. So let's start, because I will not just show, I will explain it also. So what is given to you is the velocity with which the object is thrown upward. I already drew it here for you. 14.7, arrow is upward, because it was on the platform from where it was thrown. So when it will fall, it will come down here. So that's why the distance is 19.6 and it is downward from the position where the ball was thrown. And when we are talking about vectors, we only talk about final position and initial position. So from the initial position, the final position is downward. It is acting downward. So that's why we will change the arrow upward, because we have to put the values in the constant acceleration formula, all the values which are in the same direction of arrow. And A is again, because it is always acting down, when you are throwing something up, the arrow changes and it will be minus 9.8. So now these are your 3 values, this one, and this one. If you will have any question or query on this, you can write in the comment, right? And now I have simply substituted the value in the formula. S is equals to ut plus half at square, and calculated it. Time cannot be negative, so this we will ignore and we will take this time, right? So the ball reached the ground after 3.94 seconds. The last part, the velocity of the ball when it hits the ground. I think this is easy for you, so I'm just showing it straight here. And again, 3 significant figure you will highlight. Why I have not written minus here? What is the point? Because I'm just telling you this arrow. So either you write minus sign, which will show acting downward, or you can draw the arrow. So both have the same meaning. Now the last quiz for you. this has something which is tricky, not in this question, but the question can be asked in another way. So first of all, you solve it, then I will tell you what is the tricky part at times the way it is asked. So I'm showing you the answer and you will put the video on pause. So first of all, whatever is given in the question, always draw the arrows. Again, the particle is projected upward, and this time distance is also covered up. So according to the situation, something is thrown up from here, and of course after some time it will come down, right? After some time. So suppose till this point, I'm not talking about the part when it will come down, till this point it was 50 meter. So as long as the particle is from here to here, it is above 50 meter. So you have to find out what is the time here and what is the time here. This is the meaning first time and second time. So again we are substituting the values in s is equals to ut plus half at square, and we got here 2 timings. So first time at 2 seconds and second time at 5 seconds. Now the same question is asked for how long it was above the height 50 meter. I'm repeating, for how long, rather than part A and B, the question will say for how long the particle was above 50 meter from the point of projection. In that case you will do 5 minus 2 is equals to 3 seconds. So you will say for 3 seconds the particle was above the height of 50 meter from the point of projection. So I hope it is clear to you. Thank you very much for watching the video. In next video we will solve what? We will solve past paper questions. That will be lesson 2.5. So please share it with your friends and press the like button and subscribe. Thank you very much. Take care. Allah Hafiz.